Hello, guys. My name is Desmond, and I welcome you to my lesson for today. Ladies and gentlemen, I assume at this point in time, each of you knows very well that a day without learning something new is a day wasted. By so saying, ladies and gentlemen, please do make sure that by the end of each and every lesson that I conduct, you learn something new. Very, very much important, ladies and gentlemen. So today we'll be looking at physical sciences. This is a 2015 November exam paper. Okay, so we'll be looking at question 4 of the question paper. Very, very much important, ladies and gentlemen. So guys, please do make sure that you've got something to write. That's if it's necessary for you to write down some notes. But my advice is that please do watch this lesson until the end and watch it for the second time where you write down some notes. And most importantly, ladies and gentlemen, remember, this is just to take you through the steps in which you might follow to approach this type of questions. Okay, the purpose of this lesson is not really to give you the answers or solve for these questions. Otherwise, if you need to watch a lesson where I solve this question paper, you can just you can also comment on this lesson. If you are able to comment, then I'll be able to attend to your comments. So ladies and gentlemen, there should be a lesson where I solve this type of question step by step. Okay, but for now it's just to read through the given statements and also guide you in terms of which keywords to understand or which keywords to take into account when approaching this type of questions. Okay, so ladies and gentlemen, without any waste of time, let's now start with the question. So ladies and gentlemen, question 4, you are advised to start on a new page. Very, very much important, ladies and gentlemen, at all times when you write your exams, when you start a new question, it is advisable that you start on a new page. Okay, so what I'm going to do is to read through that given statement so that you fully understand exactly what information we are given. Okay, for now, let me actually make use of an arrow to indicate what I'll be doing. So ladies and gentlemen, for now, I'm just going to read through that given statement. Okay, so a bullet of mass 20 grams. Very, very much important, ladies and gentlemen. A bullet of mass 20 grams is fired from a stationary rifle of mass 3 kg. Okay, a rifle of mass 3 kg. Assume that the bullet moves horizontally. Very, very much important, ladies and gentlemen. Immediately after firing, the rifle recoils. I'm not sure if you are able to see where I'm reading, ladies and gentlemen. Immediately after firing, the rifle recoils, which means it moves back with a velocity of 1.4 meters per second. Ladies and gentlemen, it's very, very much important that you are able to visualize this given statement, okay? Because in most of my previous lessons, I've always been indicating that, the given statement, in most cases, it's a representation or a representative of the given diagram, okay? And also, I've mentioned a couple of times, ladies and gentlemen, almost in every lesson that I've been doing where you're given a statement followed by a diagram, I've been saying, you might not be given all the information in the statement, okay? So do not assume that since you're familiar with this type of diagrams, then you can just straight away try to answer the questions based on the given diagram. Okay, so what matters the most in this case, ladies and gentlemen, I just want you to notice something very, very much important, guys. Can you see all of that given information? All of that given information, guys, it seems like we do not have a diagram for that statement. Okay, so I'm saying do not confuse that statement, or that given diagram with that given statement, ladies and gentlemen. Why am I saying all of this, guys? It's because this given statement, okay, it's followed by a question, which means for us to answer this question, ladies and gentlemen, we do not need to refer to that diagram. Ladies and gentlemen, for now you need to know that all that you're focusing on is that information and the question that comes after that given statement. Very, very much important, ladies and gentlemen. So I'm just going to quickly read through that statement for the last time. From there, we'll try to make a drawing if need be, so that you are able to understand exactly what is going on over there. So, ladies and gentlemen, we've got a bullet. So now I'm reading that statement for the last time, ladies and gentlemen. A bullet of mass 20 gram is fired from a stationary rifle of mass 3 kg. Guys, very, very much important information given over there. So let me just try to draw something, guys. Let's just assume this is a rifle, guys. I'm not good in drawing, but I hope you're convinced that this is a rifle. Okay, so ladies and gentlemen, what is the mass of this rifle? Okay, so the mass of that rifle, ladies and gentlemen, it's given over there. It's given over there as 3 kg. Very, very much important, ladies and gentlemen. 3 kg. Okay, and again we've got a mass of the bullet given as 20 grams. Okay, so ladies and gentlemen, let me draw a bullet inside the rifle. Okay, so I still have my arrow there. Let me have a pen. So ladies and gentlemen, we've got a bullet of mass 20 grams. Very, very much important, ladies and gentlemen. And again, we've got a rifle of mass 3 kg. Can you see the difference between the two, ladies and gentlemen? We've got a mass of the rifle in kgs. We've got a mass of the bullet in grams. Okay, so guys, which means it's very, very much important for you to convert from grams to kilograms. Okay, very, very much important, ladies and gentlemen. Remember, in physical sciences, we measure the mass in kilograms. Okay, so that means you will need to divide that 20 grams by 1,000, ladies and gentlemen. 1,000. The answer that you get, ladies and gentlemen, is in kilograms. So that's how you convert from grams to kilograms. Very, very much important, ladies and gentlemen. That's something that I wanted you guys to notice. Okay, so for now, ladies and gentlemen, I want you to notice something. Remember, they said that this bullet, ladies and gentlemen, is fired from a stationary rifle of mass 3 kg. There's something very much interesting, ladies and gentlemen. Remember, guys, this bullet, okay, this bullet is inside that rifle, which is stationary. What does it mean? It means the velocity, ladies and gentlemen, of that rifle, okay, the velocity of that rifle is equals to 0. Why am I saying this? Is because the rifle is stationary, ladies and gentlemen. So now, what about the velocity of that bullet, ladies and gentlemen? It has to be 0. Why? Because the bullet is inside that same rifle, okay, which is stationary, ladies and gentlemen. Very, very much important. So now we can write there to say that velocity of the rifle and a bullet, ladies and gentlemen, both of velocity of both the rifle and the bullet is 0. They are both not moving. Okay, so I'm done explaining that part of the velocity. Something very, very much interesting, ladies and gentlemen. The mass, okay, the mass of the rifle, ladies and gentlemen, it's combined with the mass of the bullet. Okay, why? It's because initially, ladies and gentlemen, the bullet is inside that rifle. Okay, that's why they've got a combined mass. Very, 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 massively important, ladies and gentlemen. Massively important to understand that information. Okay, so guys, just to remind you, I've done a complete lesson where I teach you from the start this chapter of momentum. That's where I teach you the principles, the types of problems associated with this chapter. So ladies and gentlemen, I've also covered this type of a problem. I think we've got about 5 or 6 type of problems, ladies and gentlemen, under this chapter, where as soon as you're given the statement, already you're able to know what type of a formula to use. Okay, but in this case, ladies and gentlemen, I'm just taking you through this process so that you understand how to approach and how to interpret the given information. Okay, so ladies and gentlemen, I think with regards to the velocity and the mass, I've explained all that you need to understand. Okay, most importantly, ladies and gentlemen, they're saying assume that the bullet moves horizontally. Okay, so what I like about that statement, ladies and gentlemen, if it moves horizontally, it means somehow you might find that those equations of equations of motion, ladies and gentlemen, they might also be applicable. Okay, remember, I've also done a lesson where I explain in detail equations of motions. Okay, obviously we normally use those equations under vertical projectile motion, ladies and gentlemen, where objects are moving vertically, upwards and downwards. Okay, the very same equations may be used for objects moving horizontally. Very, very much important, ladies and gentlemen. Whether going to the right or to the left, doesn't matter, as long as the objects are moving horizontally. Okay, so ladies and gentlemen, that's why you need to fully take into account that given information. Remember, guys, at all times, every information given is very, very much important. Okay, they cannot give you an information which won't be useful for you to answer the questions. Okay, that's why at all times when you read, please do make sure that you read everything and you're able to interpret the given information. Okay, that's what I teach in most of my lessons where I solve this type of questions. But remember, guys, for this purpose, I'm just taking you through the given information and how to interpret that information, and most importantly, ladies and gentlemen, the approach in answering the question. So now let's move and continue to read that statement. So ladies and gentlemen, this is where I am. Immediately after firing, okay, immediately after firing, the rifle recoils. It moves back, ladies and gentlemen, with a velocity of 1.4 meters per second. So it seems like we've got two situations, ladies and gentlemen. We've got two situations where we've got let me see where we've got that rifle with the bullet inside, ladies and gentlemen. Okay, let me just use a different color with a bullet inside. Okay, so now immediately after firing, ladies and gentlemen, we've got obviously the bullet. Okay, and again we've got a rifle, ladies and gentlemen. We've got that same rifle. Okay, so something very much interesting, ladies and gentlemen. They're saying immediately after firing, the rifle recoils, it moves back. You can see with the arrow they have tried to indicate. So it moves back with a velocity of 1.4 meters per second. Okay, very much important, ladies and gentlemen, massively important. Remember, guys, in physical sciences, it's very much important to consider the directions. Okay, very much important, ladies and gentlemen. So we can assume to the left as negative direction and assume to the right as positive direction. Okay, so already, guys, you are able to notice that this will be a negative value. Why? Because it recoils, it moves back with that velocity of 1.4 meters per second. Remember, guys, in physical sciences, a negative sign or a positive sign, it only tells the direction. Okay, it doesn't mean you should compare, for example, 1.4 and compare it with negative 1.4 and say this is a smaller value compared to that one because this one it has a negative. Okay, that's not how it works in physical sciences. It simply means, ladies and gentlemen, that it's 1.4 is the same velocity, okay, but in opposite directions. Okay, I hope you fully understand that part, ladies and gentlemen. That's why when it comes to drawing the graphs, most of my learners, they fully understand when I draw the graphs. For example, a graph of velocity versus time, acceleration versus time, displacement versus time. It's because they fully understand in physical sciences that the negative or the positive refers to the direction. Okay, very much important, ladies and gentlemen. So now, guys, a very good question may be asked. What is the velocity then of that bullet after firing? Very much important, ladies and gentlemen. What is the velocity of that bullet as it leaves the rifle? Okay, guys, this is the information after what? A very good question. After firing. Okay, ladies and gentlemen, this is the information before. Guys, before what? Before firing. Okay, very much important. What information do we know about the information before? Because we already know the information after, ladies and gentlemen. We know that that rifle, it recoils at that velocity. We don't know the velocity of the bullet as it leaves the rifle. And again, remember, guys, the mass doesn't change. The mass of that bullet is still the same as the mass before. Okay, the mass of that rifle is still the same as the mass before. I mean, the mass after is the same as the mass before. Very much important, ladies and gentlemen. So now, what information do we know about the situation before? Ladies and gentlemen, we know the velocity of both is equals to 0. Okay, we know the mass of the rifle is given as 3. We know the mass of the bullet, ladies and gentlemen, it's also given, but very much important, you need to be careful, it's given in grams and you need to convert it to kilograms. Very much important, ladies and gentlemen. So now I think we can see from that scenario, ladies and gentlemen, the only thing that we do not have is the velocity as it moves the rifle. What velocity? The velocity of the bullet. Okay, so guys, I'm going to remove all of that information and straight away check what the question says. So ladies and gentlemen, this is where we are. 4.1, calculate the speed at which the bullet leaves the rifle. Guys, can you see from our interpretation we were able to notice that something is missing. Okay, something is missing, ladies and gentlemen, and that which is missing is exactly what the question wants you to calculate. Ladies and gentlemen, what is the cream of that question? Remember, guys, the cream of the question is that word or those words on this question, when removed, will result in the whole of this question not making sense. Okay, so ladies and gentlemen, if you remove calculate, you remain with the speed at which the bullet leaves the rifle. Already you are able to know that you can calculate the speed. Okay, if you remove, I'll just focus on the keywords. If you remove speed, ladies and gentlemen, you remain with at which the bullet leaves the rifle. Okay, at this point in time, ladies and gentlemen, you cannot say based on this information you understand exactly what the question wants you to calculate. Why? Because it could be the force at which the bullet leaves the rifle, it could be the speed, it could be the velocity, it could be whatever, ladies and gentlemen. So it seems like when you remove that word, ladies and gentlemen, speed, when you remove that word speed, the whole of this, it doesn't make sense. Okay, you won't know exactly what the question wants you to do. Remember, guys, the purpose of identifying the cream of the question is for you to be able to know exactly what the question wants you to do. Okay, so guys, what does this question wants us to do? They want you to calculate the speed. Okay, so that means finally you should be saying speed or velocity is equals to whatever, ladies and gentlemen, in meters per second. Very, very much important, ladies and gentlemen. If you do some calculations and you find your final answer in kilograms, in meters, in hertz, in kilograms, meters per second, ladies and gentlemen, is completely wrong. Okay, it's completely wrong. We just want an answer which is in meters per second. How do I know? Because the cream of the question is that word, the speed. Guys, I assume we're on the same page when it comes to that part. Okay, so now, ladies and gentlemen, let me show you something very much interesting. Remember, guys, this is the type of question where you know initially you've got the mass of the rifle combined with the mass of the bullet. Okay, both of these, ladies and gentlemen, they've got the same velocity. Okay, so I'm just teaching you on how to formulate an equation for this problem. Remember, guys, I've just explained that we've got situation before and situation after, and we know a situation after there's a separation. Okay, so that means we're going to have the mass of the rifle and its velocity, ladies and gentlemen, of the rifle, okay, added to the mass of the bullet and velocity of the bullet. Okay, notice the difference, ladies and gentlemen. You've got the situation before where everything is combined. You've got the situation after where everything, ladies and gentlemen, is now separated. Okay, but what matters the most is for you to know that mass of the rifle is the same on both sides of the equal sign. Okay, and again, mass of the bullet is the same on both sides of the equal sign. Okay, remember, guys, very, very much important, your velocity on the situation before is 0. Why? I've explained that they said stationary. Okay, massively important, ladies and gentlemen. Stationary, at rest, not moving, simply means the speed or velocity is equals to 0. Okay, so guys, let's now have a look at the situation after. Okay, we are given the velocity of the rifle after firing. Very, very much important, ladies and gentlemen, and most importantly, remember it moves in that direction. Okay, so that means you should be careful in terms of the signs. Okay, obviously the bullet, we already know it's going to move in the opposite direction, so you might find that if you substitute a negative velocity there, your final answer in terms of velocity of the bullet should be a a sign which is a positive, or the opposite sign. Okay, so guys, it doesn't really matter if you choose a, to the left as positive and again to the right as negative. Okay, you just need to be careful when you substitute, and most importantly, it's very, very much important that you tell us, please do tell us, to say to the right positive if you assume to the right as positive, to the left as negative, so that we understand what's going on when you substitute. Massively important, ladies and gentlemen. So guys, you are given 4 marks, okay, for answering that question correctly. Obviously, I'm thinking that for identifying the correct formula, you might get a mark, ladies and gentlemen. You might also score 2 marks for correct substitution, and again, you might score a mark for your final answer. Okay, so guys, someone might ask myself a question to say, our final answer, does it really need to have a direction? Ladies and gentlemen, I'm going to say not really. Why? Because they said calculate the speed. Okay, a speed is a scalar quantity, which means it does not have a direction, but it only has a magnitude. Let's say when you calculate, ladies and gentlemen, you find your speed to be 210 meters per second. Okay, so you can either say v it's equals to, or otherwise say speed is equals to. Okay, then this is the answer that we get, ladies and gentlemen. No need to say to the right or to the left. You can just give that answer. That's it, ladies and gentlemen. So now let's quickly move let's move on with the question. So now, ladies and gentlemen, we are given another statement over there. They say the bullet strikes a stationary 5-kilogram wooden block fixed to a flat horizontal surface or table. Very, very much important, ladies and gentlemen. The bullet is brought to rest after traveling a distance of 0.4 meter into the block. Refer to the diagram below. What an interesting statement, ladies and gentlemen. I'm just going to try and make sense out of that statement. So they're saying the bullet, which is obviously that bullet, ladies and gentlemen, strikes a 5-kilogram wooden block fixed to a flat horizontal table. So ladies and gentlemen, it means this block, it's fixed, it's not moving. Okay, it's attached to that horizontal table. Okay, so the bullet is brought to rest after traveling a distance of 0.4 into the block. So ladies and gentlemen, you can see this is the situation before and this is the situation after. Okay, so this bullet, it travels that distance of 0.4 meters into the block. Then, ladies and gentlemen, it's brought to rest, which means it stacks or it stops within the block. Okay, very, very much important, ladies and gentlemen. So now it's more like we've got another situation of before and after. In this case, we're given a diagram which represents that situation of before and after, but in this case we're not given that situation, we had to draw or visualize it. Very, very much important, ladies and gentlemen, that you are able to interpret the given statement, visualize, and also represent that given statement in a form of a diagram. Okay, massively important, ladies and gentlemen. So now let's see, ladies and gentlemen, we've got the situation of before and after. Okay, so I'm not really sure in terms of if there's a need for me to go deep into explaining this information, but let me just quickly do that, ladies and gentlemen. Obviously, guys, you can see, I think almost everything, it just makes sense, ladies. Remember, guys, in this case, you've got a mass of 5 kilograms. You still have that same bullet. Okay, remember, it's given in grams, so that means when you continue with your calculations, it should be in kilograms. Okay, so guys, I'm not really sure if there's something that I'm missing, of which I might need to explain. But most importantly, guys, what you need to be aware is that the velocity or the speed that you calculated here, let's assume an answer, it was 210 meters per second. That means it strikes this block at that speed. Okay, so now what is the velocity of that block, ladies and gentlemen? They just said it's fixed. Okay, or otherwise, ladies and gentlemen, it's not moving, it's attached to that flat horizontal table, which means its velocity is 0 meters per second. Very, very much important, ladies and gentlemen. Even after, ladies and gentlemen, its velocity or speed is 0. Why? Because it's fixed to a flat horizontal table. Okay, so ladies and gentlemen, obviously the mass before is still the same as the mass after, and again the mass of the block before is still the same as the mass of the block after, ladies and gentlemen. Okay, so now what other information do we need to interpret, ladies and gentlemen? I think the other information that we need to take into account is the fact that the velocity of the bullet, ladies and gentlemen, in the situation after, it's going to be 0 meters per second. Okay, remember, that means the velocity of the bullet and also that of the block is equals to 0. Okay, so now let's try to move on to the next question, ladies and gentlemen. So obviously, guys, I assume we fully interpreted that information and you understand. Okay, so they say calculate, we're on 4.2, ladies and gentlemen, calculate the magnitude of the average force exerted by the block on the bullet. Very, very much important, ladies and gentlemen. They want you to calculate the magnitude of the average force. So ladies and gentlemen, if we remove that part, we remain with calculate the magnitude of the by the block on the bullet. It doesn't really make a complete sense in terms of what the question wants you to calculate. Okay, so guys, that means the cream of the question is that average force. So guys, give us F, which is equals to whatever, ladies and gentlemen, in Newton. Very, very much important, ladies and massively important. Only if you can do that, ladies and gentlemen, in the end, you will score yourself 5 full marks. Okay, do not give us an answer which is in meters per second. Do not give us an answer which is in meters. Do not give us an answer which is in meters per second squared, ladies and gentlemen. Do not give us an answer other than an answer in newtons. Okay, massively important, ladies and gentlemen. So guys, remember, we've got a formula of which I indicate in my lessons, ladies and gentlemen, which says F net multiplied by change in time. This is equals to change in momentum. Ladies and gentlemen, I'm not really sure if you still remember this formula. But towards the end of this lesson, we'll just check out that formula from the formula sheet. Okay, and again, ladies and gentlemen, change in momentum, this is equals to momentum final minus momentum initial. Okay, obviously we know momentum is m, which is the mass, and v, so that means this is mv final minus mv initial. Let me just indicate there is a final. Okay, massively important, ladies and gentlemen. So that means let me do that so that it makes sense. So that means that it's equals to this. So I've just expanded that change in momentum. Remember, ladies and gentlemen, this is a sign which means change. In Greek is called delta. In short, it means final minus initial. Okay, massively important, ladies and gentlemen. So since they want you to calculate the force, you can just use this formula, ladies and gentlemen, which says force net. Then you can just equate it to change in momentum, which is mv final minus mv initial. In this case, we divide it by change in time. Okay, remember guys, you had that change in time over there. We just divided by delta t to make it the subject of the formula, to make force net the subject of the formula, because that's what the question wants you to calculate. Okay, so ladies and gentlemen, remember guys, you need to be having all of this information in order for you to be able to calculate. Okay, remember, this is the part that you're dealing with. Okay, which means you've got a combined mass, ladies and gentlemen. You've got a combined mass of both the block and the bullet. Okay, so into you've got velocity final, ladies and gentlemen, minus velocity initial. Which velocity are we talking about, ladies and gentlemen? We are talking about the velocity of the bullet. Remember, this is the bullet which is striking the block. Okay, so obviously guys, we can make use of the information of that bullet to calculate the force exerted by the block on the bullet. Okay, massively important. So ladies and gentlemen, we know the bullet comes to rest. Okay, and most importantly, we know the velocity at which the bullet strikes strikes that block. Okay, massively important. So now it seems like what we don't know, ladies and gentlemen, is that time. Can you see? It's now becoming interesting, ladies and gentlemen. We don't know the time, but if you remember guys, we are given that distance, it traveled, the distance traveled by that bullet to come to rest. Okay, so they're saying the bullet is brought to rest after traveling a distance of 0.4 meter into the block. Okay, so ladies and gentlemen, that's why it's very, very much important that you watch most of my lessons, because there's a relationship between the formulas that we use for momentum and again the formulas that we use for equations of motion, for vertical projectile motion. If you remember guys, I'm just going to show towards the end of this lesson. If you remember, we've got this formula, ladies and gentlemen. We've got this formula. I think it's either V initial or V final. It doesn't matter because we are adding the two. Okay, this is divided by 2, and then this is delta t. I'm sure you are familiar with this formula, ladies and gentlemen. What exactly are we trying to calculate? We want to know the time it takes for this bullet, ladies and gentlemen, to come to rest after traveling a distance of 0,4. Okay, so what will be the velocity initial? Obviously, ladies and gentlemen, it should be that 210 that we assumed to be the initial velocity. Okay, what is the v final? Obviously, it comes to rest, ladies and gentlemen, which means the final velocity will be 0 meters per second. Can you see, guys? Then we're going to have 210 over there, which is divided by 2. I think it's 105 if I'm not mistaken, but it doesn't really matter. Then you've got 0.4, which is being divided by that 0.5, 105. Then the answer that you get, ladies and gentlemen, is the time it takes for that bullet to come to rest. Okay, as soon as, ladies and gentlemen, as soon as you are able to get that time, then obviously it means you can substitute everything, ladies and gentlemen. You've got that mass v final minus v initial close over delta time. Okay, so obviously, ladies and gentlemen, we know we've got the mass, we've got the v final, we've got the v initial, we've got that. Then we can calculate our force, which is whatever in newtons. Okay, so ladies and gentlemen, I hope you fully understand that part. Please do try to solve this question as soon as I'm done with this lesson. Okay, otherwise, if you struggle, you might be watching this lesson on my YouTube channel, website, Facebook, or whichever social media platform. Ladies and gentlemen, just do comment where you request a link where I solved this question. Okay, because there I'm going to show you the details of how you solve, in terms of the substitutions, how to identify the correct formula, where you score marks, and everything, ladies and gentlemen. So now, guys, let's move to the next question. Obviously, guys, by performing all of those calculations, you get some marks for identifying the correct formula, substitution, an answer, and again, finally, for identifying, otherwise, if not for identifying the formula, but for correct substitution into the correct formula, and finally, ladies and gentlemen, by giving the correct answer. And most importantly, calculate the magnitude of the average force. You can still indicate that it's whatever a force in which direction. Okay, so you can also indicate, because force is a vector quantity, it has both the magnitude and the direction. Okay, if you know the bullet is moving in that direction, obviously it means the block is exerting a force in that direction. Okay, so ladies and gentlemen, let's now move to the next question. Question 4.3. How does the magnitude of the force calculated in question 4.2 compare to the magnitude of the force exerted by the bullet on the block? Write down only larger than, smaller than, or the same. This question is allocated 1 mark. So guys, obviously this question, it's not that much complicated. Okay, so obviously you might not need to stress about identifying the cream of the question. Okay, straightforward question. So ladies and gentlemen, what matters the most in this case is that this object is traveling in that direction. Okay, so it's going to hit that block. Okay, so if it hits that block at 20 newtons, ladies and gentlemen, from my understanding is that whatever force the bullet is hitting that block, okay, the reaction from that block, ladies and gentlemen, it should be the same as that amount. Okay, so that means whatever force hits the block, it will be that whatever force that the block hits back. Okay, we are not interested in between the bullet and the block, which one is feeling more pain. Okay, we're interested in terms of as it reacts, by how much of the force is it reacting. Okay, so that means if you've got a wall, ladies and gentlemen, you've got a wall and you hammer this wall at 100 Newton. Okay, this wall, ladies and gentlemen, is also hammering in the same amount of force. Okay, so I won't go deep into explaining that, ladies and gentlemen. You will just answer by choosing that, or that, ladies and gentlemen. But otherwise, I'm going to go in detail when I solve this question. Okay, so ladies and gentlemen, if you are writing this 2015 exam, November exam question paper, for this question you're going to score yourself full 10 marks. It's a very straightforward question, ladies and gentlemen. So guys, I think before I sign out, let me try to check if I can find a formula sheet from my private group, ladies and gentlemen, so that I can actually explain in detail what I wanted you to notice. Okay, so ladies and gentlemen, please do make sure that you check out the formula sheet. Okay, so obviously guys, this is the formula that I used. Can you see? This is that formula that I used. Why specifically this one? Is because I knew that delta x. Okay, I knew that v initial, I knew that v final. The only thing that I wanted to calculate, ladies and gentlemen, it was the time. Okay, massively important, ladies and gentlemen, massively important that you fully understand how these formulas works. Okay, why did I have to choose from these formulas, ladies and gentlemen? It's because they said that the bullet was moving horizontally. Okay, and again, I had formulas, ladies and gentlemen. Why did I not choose this formula for calculating the force? It's because it was going to be a bit of a lengthy calculation, because I had to calculate the acceleration, perform some more calculations to calculate the time or whatever, ladies and gentlemen. So it was very much easy for me to straight away use this formula because it has all that I need. And again, it's equated to a change in momentum. Ladies and gentlemen, in one of my lessons where I go deep into explaining this chapter of momentum, I also explain the impulse, what is well known as the impulse. I won't explain it in this case because the purpose of this lesson, ladies and gentlemen, was just to take you through that question. Okay, so ladies and gentlemen, please do make sure that you check out a lesson where I go in detail when solving that question. So ladies and gentlemen, I think this is that time where I need to sign out and say my name is Desmond and I'm out.